Welcome to all. Myself, Dr. T. Sasikala, Associate Professor and Head, Department of Chemistry, Sri Ramakrishna College of Arts and Science, Coimbatore. In this presentation, I am going to discuss about conformational analysis. The free rotation among the carbon-carbon single bond gives rise to infinite number of arrangements of atoms or groups. This infinite number of arrangements of atoms or groups of a molecule in three-dimensional space which are interconvertible into each other by rotation about the single bond are called conformations. It is also known as rotational isomers or rotamers. The study of molecular conformations and their energies is known as conformational analysis. It allows us to relate the shapes of the molecules with the chemical reactivity and physical properties. Now, let us discuss about the conformational analysis of cyclohexane. Cyclohexane has a non-planar structure which is free from ring strain. Cyclohexane exists in four conformations: chair, boat, half chair and twist boat conformations. Now, let us see the first conformation, chair conformation. It is the most stable conformation. Cyclohexane exists predominantly in non-planar puckered chair form. In this conformation, all the bonds are staggered. Therefore, the pitch strain is minimized. The dihedral angle for staggered conformation should be 60 degree, but in this form, it is around 56 degree. As a result of this, slight flattening of the ring occurs. Now let us see about the axial and equatorial bonds. The 12 carbon-hydrogen bonds in the chair form is divided into two forms. One is axial bond and second one is equatorial bonds. Axial bonds. The 6 carbon-hydrogen bonds which are parallel to the axis are known as axial bonds. It is represented by the letter A. Equatorial bonds. The 6 CH bonds which extend radially outward at an angle of 109 degree 28 minutes to the axis are known as equatorial bond. It is represented by the letter E. Now let us see what is ring flipping. The chair form of cyclohexane easily flip at ordinary temperature and the molecule will assume a second chair form in which all the CH bonds which are axial in the former will be equatorial in the later and vice versa. Second conformation is the boat conformation. In the boat form of cyclohexane, there is a complete eclipsing of hydrogen atoms attached to the carbon atoms forming side CH2-CH2 bonds. The inside hydrogens at the carbon 1 and carbon 4 called the flagpole hydrogens interfere with each other sterically, leading to instability of boat form compared to the chair form. This interaction is known as transannular interaction. The third conformation is the half chair conformation. This is the least stable conformation because carbon atoms at one end of the ring are planar. It is a twisted form of the chair conformation. The last conformation is the twist boat conformation. The boat conformation is a less stable conformation due to eclipsing on its side carbons and due to transannular interaction between the flagpole hydrogens. Twist boat conformation is stabilized by moving apart the flagpole hydrogens, thereby minimizing the transannular interaction. The stability order of cyclohexane. The chair form of cyclohexane is the most stable among the twist boat, boat and half chair. Cyclohexane has the ability to switch between the conformations and only chair and twist boat conformations can be isolated in the pure form. Due to the hydrogen-hydrogen interactions in these conformations, the bond length and bond angle vary slightly from their nominal values. The boat conformation of cyclohexane is not a very stable form due to the torsional strain applied to the cyclohexane molecule. Twist boat conformation of cyclohexane are much more stable than their boat-shaped counterparts. Energy level diagram. The relative energies of the conformations is the direct reflections of the relative stabilities. These structural and energy relationships were summarized in this energy level diagram. The activation energy for the chair-chair conversion is due chiefly to a high energy twist chair form in which significant angle and eclipsing strain are present. A facile twist boat and the boat equilibrium intervenes as one chair conformation changes into the other conformations. Thank you.